How's it going, guys? This is the big one, the one which I'm sure you've all been waiting for. I'm going to teach you how to solve equations, and I'm going to introduce this thing called scales. But anyway, that'll come in a second. So, as you obviously, I hope all of you watched that video I did earlier. I think I called it algebra, the big picture or something. And I talked about how there are only two types of algebra questions, and the first one was rewrite questions. And the second one was where you actually kind of found something out. Found an unknown value, or literally you're finding out something you don't know. I think that's literally. So the rewrite stuff, I've shown you how simplifying terms, expanding or multiplying out brackets, whatever you want to call it, it's the same thing, and factorizing. So with these, the first type of algebra question was just rewriting a certain bit of kind of algebra with a few x's and stuff like that, and kind of writing it in a different way. So, you know, there might be simplifying terms, did that, expanding, factorizing. If this doesn't make sense to you, you need to go back. You need to go back, but hopefully it does. And the second one is now what I'm going to show you. It's a case where the question is going to tell you a little bit of information, but you yourself are going to have to find out what that actual number is. Kind of like a detective novel, really. They give you clues, but they don't tell you who it is, and you've got to, well, I don't know, Sherlock or something's got to go figure it out. Well done. You're now stepping into the shoes of Sherlock, into the maths world, except you get no Watson, so you're all by yourself. So anyway, so yeah, listen. What I'm going to say with this is the questions I'm going to go over, the examples, for a lot of you, you're going to see that and think this is incredibly easy. But I still say, listen, you have to watch this video. Because here's the deal. You might be able to do these questions, but algebra keeps getting harder. What I'm doing is I'm trying to get you to the point where you can do any algebra. And what's going to be more important here isn't the answer to the questions which I'm going to put up, but more the thinking. Why am I doing what I'm doing? What's the reasons behind it? As opposed to just knowing what to do. Once you know that, all of the algebra that keeps coming beyond this is just a little variation. But most of you guys don't fully understand why you do what you do. So watch this video really carefully. Anyway, that side. So let's start with, a relatively straightforwardish algebra question. Something like this. So it's saying solve 2x minus 10 equals 14. And let me tell you why this is this is one way you're trying to figure out the value. This is saying you've got to first fully understand what this part of the question is saying. This part of the question is saying, look, there's a number x, which if I multiply it by 2, so if I double it, then take away 10, I'm left with 14. And then it's saying, go find that number. So obviously, then most of you probably know how to solve this, but let's just take a step back still. So, first off, we want to be very clear in our heads how we can test, how we could almost try even guess, or if I gave you, say I gave you 3 options. Say I told you that one of these is the right answer. How would you know? So I'm not saying about going about finding it out using like algebra and showing you working. Let's first kind of understand what makes the right answer. So first things first, let's try this one out and I'll show you how we do that. We literally replace x with 10 and see what happens with this equation. So if I put x equals 10 in there, hopefully most of you get that 2x is going to become 20. So okay, I've literally substituted it into the equation here. Just that x, obviously this is 2 times x, I made that x 10. So 2 times 10 is 20 minus 10. 20 minus 10 is 10. And look, you get to the situation where you get, absolute rubbish. You've got to the point where someone's telling you 10 equals 14. So that's why this is not the right answer. So now let's kind of substitute in x equals 12. So similarly, let's try this. Right, 2 times 12, remember BODMAS, we're not going to take these away first, we're just going to do that. So that's 24 minus 10. 24 minus 10 is 14. And look, when you actually plug x equals 12 into here, you do actually get that 14 equals 14, which is what you should hope for. And, quickly, just this will be wrong as well, so this is correct. Let's give it a green tick. And hopefully a lot of you can kind of see why 15 will be wrong. 2 times 15 will be 30 minus 10, that would give you 20 equals 14. Again, it's rubbish. So that's how you know. And here's the deal as well, what I shouldn't. So once we go through learning how to solve all types of algebra questions, much harder than this. One thing, so once you actually find your answer, you can make sure that it's correct by then looking at the original question and plugging your value back in and making sure it balances. So keep that in mind. Now, let's actually think about how you work this out if you didn't know how to do this. And it all comes, and this is how you do it. This is the thinking I want you to have. Now, obviously, you don't know what x is, but you do know that 2 lots of it, take away 10, is exactly the same as 14. Now, this is what I'm going to mean by the scales. So, let's introduce. So, hopefully you guys can see. So, remember, 2x minus 10 is supposedly the exact same as 14. So, let's think about those like old Roman or, I don't know, maybe Greek scales. Not sure where they're from. So here's the deal. If I put 2x minus 10 on one side and 14 on the other side, that would balance perfectly, right? That would literally balance absolutely perfectly. So, but here's the deal. If you look at this, can you see it's not straight away very obvious what x is? So here's what I want you to think about. Imagine if we could somehow get to this situation. Somehow, and I'm sure I'll tell you how. Imagine if we ever, and I'm not saying this, what I'm going to show you is the answer to this, obviously, but let's just say for some reason, like we could somehow mess this around so we get to that. So you literally got x on one side, 7 on the other side, and they're balancing perfectly. What do you think x would have to be in this situation? Have a think about this. And hopefully most of you said x would have to be 7. Because if there's 7 on one side and literally x by itself, just one x by itself on one side, remember balancing perfectly with 7 on the other side, then x has to be 7. There's no other way it can balance. So this is, whenever you're given a question like this in algebra, and it doesn't matter what kind of algebra question it is, you're going to see quadratics, you're going to see stuff with fractions on the top and bottom, simultaneous, it does not matter. This is your aim from now on. You want to get to this. So that's what, so I'm going to put this up here. Our aim is to kind of mess around with this so that we get x equals whatever on the other side. By the way, there can be no x's here. And what I mean by that is this is the only x on either side. This is the only one. Because can you imagine if there was now, like, I don't know, 2 x's? Again, it wouldn't be clear. So that's why we want to get it to a point where x is by itself on the side and it is the only x on either side. Once you get it to this, it's just an easy read-off. So this is massive, right? This is going to be our aim. This is what we're going to be shooting for every single time. So now, I want to bring in a little analogy. So, alright, so the next thing is, alright, how do we start from here? Maybe I shouldn't have rubbed that last bit out. Okay, so how do we start from here? Remember, these two things are the same thing, essentially. I'm just drawing it like it would scales. How do we get this to that? Okay, the first thing I want you to step back. Now it is going to be analogy time. So here's the deal. Like, when I was a kid, I used to have this thing. Let me actually get a proper picture up of it. Alright, we are recording here. Okay, so what I was talking about. So I'm telling you how this fits in. So I used to have one of these puzzles before. Now, here's the deal. Obviously, these are kind of completed. But obviously, you would kind of scramble this up. And, you know, if I scrambled this up and gave it to you, why would you make a move? You know, if you decide to slide a certain piece in a certain direction, why did you do it? You know, what was the reason behind it? And hopefully, you guys agree that it's simple as this. You thought the move which you were making was going to get you back to this finished position. Alright, well now, when you get an algebra question like this, right, so think of this as your jumbled up puzzle. And I want you to think of this, which is the same as that, yeah? When you get to x, just by itself, it doesn't matter what this is. Yeah, so this is your jumbled up puzzle. This is what you want to get to. So here's the deal. With algebra, you're actually going to do the exact same thing. When you make a move, and I'll tell you what I mean by a move in terms of algebra, the only, and I literally mean the only reason you do it is because you think you're getting closer to that. That's it, nothing else. So let me show you this now. So let me kind of show you a few moves which you could do. So, for example, right, so we've got this right now. So here's a move I could do. So right now, remember, 2x minus 10 is balancing perfectly with 14. So here's one thing I could do. I could add 1 to this side. But obviously, can you see, because these originally were balancing perfectly, if I add 1 to this side, obviously this side becomes heavier. So here's the deal. If I want to add 1 to this side, I have to add 1 to this side. So as you do for algebra, it's all about keeping the balance. You have to keep the balance. Now, so by doing this move, and that's what we call it, you know, we add 1 to each side. And you're going to notice this. Whatever you do to one side, you have to do to the other. Otherwise, you screw up the balance. So now let's look at what actually happens if I add 1 to this side. So I already had 2x minus 10, now I'm just going to add 1 to this side. Now hopefully from simplifying terms, do you see now, look, the reason they showed you how to simplify terms is you can actually clean this up. This just becomes now 2x minus 9, and this will just become 14 plus 1, which will give you 15. Do you see, by adding 1 to each side, we've actually changed the equation. But now, here's the deal. So, the next thing you've got to say to yourself, well, alright, was that a good move? And remember what makes a good move. Literally, all that makes a good move is, do we now believe that now that we're here, are we closer towards our aim than we were here? And the question, and hopefully you can see, not really. We still have this 2x, and we've still got these two numbers on each side. So really, our move wasn't a particularly good one. So, but it didn't take us further back. So I guess it's not the worst move in the world, but it didn't really help us. So, you know, not a particularly good move. So what does, by the way, so let me now just show you a few more other moves you could have done. Yeah, so we could have added 63 to each side. Well, I could have added 63 to this, as long as I do the same thing. Hopefully you see that's still going to balance. Yeah? So it doesn't really matter. I can add any number to this side as long as I do it to this side. I can take away any number. Let me show you an example. I could take away 12. As long as I took away 12, what would I do? What would happen? So here you go. I've got 2x minus 10. If I took away 12 from here, by simplifying terms, I'll get to here. Obviously now here, I had 14, I'm taking away 12, becomes 2. You see? But again, this isn't closer to here than it is here. So I'll rub this out because it wasn't a good move anyway. So here you go. So there I've told you a few moves. You can add anything to each side, and you can also take away any number from any side. So let's look at a few more. I could, and here's the next thing, I can multiply each side by 3 if I wanted it. Because here's the deal, why can I do that? So if I multiply this side by 3, all I'm literally doing is I'm taking what there was, and I'm now making this side 3 lots of. But at the same time, I've got to do the same thing to the other side. So I take 3 lots of that. Now think about it. Originally, this 2x minus 10 balanced with this 14. So obviously these two are also going to balance. So all of this is going to balance with all of this. So here's the deal. So let's kind of look at all of the moves. We can add by any number. Subtract or take away by, well, I say any number or anything. Because here's the deal as well. The reason I'm saying anything and not any number is because hopefully you kind of see, like, look, imagine that stuff wasn't there. I'll clean this up in a second. If we have this and I decide to add x to this, obviously I don't know what x is, but as long as I add the same x on the other side, I've still got a balance. And that will also change the equation. Hopefully you know that this, using simplifying, would now become 3x minus 10. This side, which is going to be 14 plus x, you can't really simplify that. So, you know, we can change it to that. That definitely is not a good move, because before we had just like a certain amount of x's minus a number equals a number. Now we've got x. We've got x's on both sides, which is definitely taking us further from just wanting x by itself on one side. So, okay, oh yeah, where was that? It's a little bit scrambled with my thoughts, but hopefully you guys are following me just fine. Hope so anyway. So here's the thing. You can multiply by anything, and you can divide by anything. Just remember, it's got to be, whatever you do to one side, you've got to do to the other side. So now let's think about this. So now we know what we're doing. We now know the moves we can make. We've got to try take this to that. So remember, let's kind of just remember this as well. So let's look at that scales equation again. You know what? Let me put the x in red, because here's the reason I'm putting it in red. Here's the deal, don't forget our aim. We just want that x by itself. Literally by itself. We need all of this other stuff gone. And on this side is 14. So here's the first thing we do. So think about this. What if I add 10 to each side? And this is going to be a good move. Let me show you one. So we had 2x minus 10. Now we're adding 10. So by simplifying terms, minus 10 and plus 10, they're literally going to make 0. They're going to cancel each other out. So we're left with 2x. This side is just 14 at 10 equals 24. So we can literally take this equation to 2x equals 24. Now ask yourself this. Is this closer to our aim of getting x complete by itself than this? Well, yes, because this had numbers on both sides. In this, we've moved all the numbers to the other side. So we are closer. And now, so here's the deal. This is a good move. And that's literally the only thing that makes it a good move. The reason it's a good move is because this is closer to that than this is to that. That's it. Nothing more. So let's carry on. So now we have a new position. Now we are here. Okay? So now think about this. What are we going to do next? Well, let's think about this. We've got two lots of x. So this literally means 2 times x. We just want this x. How can we get rid of that 2? Well, we just do the opposite. Do you remember how there was a minus 10? So because we wanted to get rid of that, we added 10. Well, now this x is being multiplied by 2. So to undo that, we divide by 2. We divide this side by 2. Right? So this side becomes x. Now don't forget, because we divided this side by 2, we have to divide this side by 2, or we lose that balance. So 24 divided by 2 is 12. That's how we get our answer. Hopefully that makes sense to you. So that's how we figure this out. One second, bear with me. Right. Now, here's a few things I want to show you. You should never kind of fall into the trap of. Do not. So I'm sure in the past you've kind of heard, well, some of you would definitely have heard, that some people say, you know, if you're here, they'll say, oh, you just move this 10 to the other side. That is completely wrong. That's not true. And hopefully you can realize now that instead what we actually did was we added 10 to this side, to both sides, which made this cancel. But that we weren't moving this 10 to this side. That never happened. We actually added 10 to each side. And that's a really important thing. Because whilst it's easy to keep solving these equations using that kind of thinking, because it's pretty simple, you've been shown that way. But the whole point here for me is I'm trying to get you to the point where you can solve the hardest equations. These tough quadratics, these simultaneous equations. If you put a little bit of time into this, I virtually promise you, you will see it become very, very easy. So anyway, remember those rules. So don't fall into that trap. So let's kind of have a look at a few other kind of common mistakes that some people make. So, and I think this is important as well because you guys will make this. So some people sometimes confuse what comes first. So you'll be at this stage. Let's say this. Sorry about the delay. Right, so we're at this stage. You've got 2x minus 10 and 14. Some people think, oh, it's 2x. Let me divide by 2. Now, there's nothing wrong with that, but this is the problem they do. They end up doing this divided by 2. So they divide that by 2. They leave that 10 there, and then they divide the other side by 7. Now, there's a massive, massive mistake, because you're not thinking scales-wise. And one of the reasons I actually do this scale thing is I want you to know that you can't do anything to this 2x by itself. You can't do anything to this 10 or minus 10. You can't do anything to this 14. You can literally do it to this whole side and this whole side. That's it. So here's the deal. If you're going to divide, you can't divide this by 2. You can divide this whole side by 2. And here's how you do it properly. So you've got 2x minus 10. So if you want to divide that side by 2, you've got to divide the whole side by 2. Now, for you guys who know your fractions reasonably well, if you don't, just watch this and don't worry about this. A simple way of putting it is you'd have to divide the 2 and the 10, because this 10 is also on this side. So if you do it correctly, and you got to this, there's no problem with that. But the real reason it happens, and you guys might not get this because you probably haven't gone to the fractions video, is you can split this. You can split this fraction up to that. Because here's the deal, look, think about this. You know, if you have like say you had 5 over 7 and you were taking away 2 over 7. If you guys know your fractions well, you end up, the reason is you get to that. Well, here's the deal. The reason you can do this is the denominator is the same. Guess what? If you had a look at that, the denominators are the same. If you were going to join those up, this is what will come. So how when you can, even though you can, if I gave you this, it's probably easy for you guys to know that it goes to this. Understand as well, you can split it up. Now this one, if you know how to cancel properly, you know that 2x over 2 becomes x minus 5. So that's why it happens. So that's a really important thing. You've got to understand that you're doing stuff to the whole side. You're not doing it to any individual bit of a side. Right? You are not. You've got to know this. So let's, so hopefully that example makes a lot of sense. So let's move on swiftly to the next question. So now I'm just going to go through more things, but I'm also going to, that was the most important thing. I say keep watching on anyway for a few more examples. Let's pick something a little bit, let's do one more very quickly anyway. So 5x equals 2x plus 12. Okay? So yeah, let's think about this. We've got, so this is a harder question. Much harder, but harder. Okay, so the reason I put those x's in red again, because don't forget, our aim, the only reason we do something is if we want to get, it could be, whatever, you know what I mean. The only reason we do a move is because we feel we're getting closer to our aim. This aim is the only thing we look at, that's what we work towards. So anyway, so now if we have a look at this, if you have a think about this anyway. So listen, guys, pause it and try to solve this. Some of you probably know this immediately, but pause it, have it go. Alright, hopefully you pause it and actually bother to give it a go again. Here's the best way to do it. So look, notice sometimes it's worth kind of stepping back and thinking, right, what's annoying about this question? And what's annoying is we need to get x by itself on one side. But do you notice we've got x's on both sides? So we need to sort that out. Somehow we're going to have to make them 1. The number on the other side isn't really a problem. But what is annoying is we've got x's on both sides. Here's what you do. What we're going to do is, usually a good rule is, get rid of it on the smaller side. Yeah, so if I take away 2x from this side, hopefully you can see I'm going to be left with 12. Because that 2x plus 12 minus 2x, those 2x will cancel. Remember, if you take away 2x from this side, you got it from this side. But this is useful. Look, so we've got 5x. We had 5x, now we've taken away 2x. What are we left with? We're left with 3x. So if we do that, we literally move to 3x equals 12. And obviously that's way better. So now, so this is the situation we're at now. Yeah, we've got 3x equaling 12. Hopefully you guys look at this same 3 lots of 12. Now we're dividing each side by 3. So, some people actually, this is actually a good kind of practice to get into. Some people like to write it on both sides as you go along. And here's the deal, always know, as you write your working out, be very clear in your head what you've done at each side. Because if you're clear in your head about that, inequalities, if any of you have problem with inequalities, it is going to be the simplest thing in the world doing inequalities algebra, as long as you understand what you're doing to each side at each stage. Simple. But for the time being, hopefully you can see we get to x equals 4. Remember, we can check this as well now. So let's put it in. 5 times 4 would equal 20. 2 times 4 would equal 8 plus 12. 8 plus 12 is 20. Yep. Alright, so next question. So now remember how I told you about how everything you were learning with the rewriting, the expanding brackets, factorizing, all of that stuff, it comes to help you in this. So let's have a look at a question like this. So they say solve 7x minus 3x plus 1 equals 7. Let's draw the scales. So this one's got a little bit extra annoyance to this. So this one's annoying because, again, we've got two x's, but one's stuck inside a bracket. Now here's where you're going to see this. What we're going to do is we are going to rewrite this bit of the equation. So let's just kind of deal with that on the other side here. And hopefully you guys have seen the expanding and simplifying video to understand how to deal with that negative and that plus on the inside. If you haven't, go watch that video. So listen, this is what we do. You see how I've highlighted this in yellow? We're going to rewrite that in a better way. And all we're going to do, so if we expand that, hopefully you guys are comfy that we get this. So here's the deal. This is what happens in the next thing. Literally, what we do is now we rewrite this bit as minus 3x minus 3. This is 7x. And remember that this yellow bit was just to kind of show you what's going on, so which bit I was rewriting. So do you see that? So look, by rewriting it, what I mean by that is just expanding the brackets. Just that little bit, if we just rewrite that little bit, do you notice I didn't change anything? I didn't do anything to each side. But I did pick that bit and say, I know a better way of writing that, which is going to be more useful to me. So that's why, in the first place, you learn to multiply out brackets. That's the only real use for it. I know they give you questions just by itself where they're like, multiply this, expand and simplify. But the reason is, it's a tool for this. So now you get to this stage. This stage is way more useful. Because you're now at this position, which is much, much easier. Right? And now it's simple. You can already, just by looking at this, you can simplify this without doing further. So again, we're rewriting it. So we've now literally expanded this, and now we're simplifying this. So 7x minus 3x, hope you guys are happy with that. And look at this, we're at such a better position, just by rewriting a little bit. Okay, and now it's simple. Look, do you see how we're at so much of a better position here? We've now got it to 1x, and we needed to expand it because that x was trapped inside that bracket. There was no way we were going to join it with this whilst it was still stuck in that bracket. So we rewrote this little bit to that, which allowed us to join these two things together by simplifying. So here you go. This was the rewrite. This was rewrite. We expanded. This is the rewrite. We simplified. Times. Yeah? And now look at this. This should be kind of reasonably straightforward if you understood the last thing. We want to get rid of this number because we're trying to get this x by itself. So let's get rid of that thing first. Don't fall into the trap of trying to divide by 4 here. If you do, you're going to have to also divide this by 4 and this by 4, which I don't recommend just yet. So yeah, let's add 3 to each side. I don't know if I said take away 3 yet, but obviously because it's a take away 3 here, we want to add 3. This will leave us with 4x here. So that it's going to go to 10. So now we're at 4x equals 10. Final thing, so here you go. So this one I'll put in green. So what we did here was plus 3 plus 3. So notice, as we move through our working out, there's only 2 things which ever happen. Either we rewrite a little bit of it, that's totally different from doing something to each side, or we actually do one of our moves, as I called it, which is just we do the same thing to each side because it helps us get to a better place. And here's the deal, everything we do gets us closer to our aim. That's the only reason we do it. We're not thinking in terms of, oh guys, whenever you see this, I want you to times by this, or take this away if you see this. That stuff is, it's a memory test. It's boring, and it makes life harder. So anyway, so where are we now? We're at, just ignore this stuff for a second. Almost just done bother writing this. But you get me, right? The next step is going to be divide by 4. Divide by 4, that gets you x. And you know, this one, the reason I'm showing you this is don't be scared, because especially in the higher paper, here's the deal, look, you're not always going to get perfect whole numbers, and that's not a problem. So here you go, you've got 10, you've got divided by 4. Just write it as a fraction. That's literally it. Just write it as a fraction. So you get to this stage, you get to x equals 10 over 4, and all you have to do with the fraction is just make sure you simplify it, cancel it down as much as you can. So if you guys see, there's like, you know, you can cancel 2 from top and bottom, and there you go. The answer is 5 over 2. You can, if you want, you can write that as a decimal if you know it's 2.5. But here's the thing: you don't have to. You don't even have to write this as a mixed fraction. My view is mixed fractions are useless anyway. Unless they tell you to write your answer in a mixed fraction, don't bother. Just write your fraction, cancel it down. You don't even need to take it to the decimal. You can, any one of these would have been the right answer, but yeah, so don't be scared if you don't get a whole number. There's nothing wrong with that. So right, so let's go to, and hopefully, you know, now a good amount of you will be getting this. So, you know, if you feel like you've really got it, I guess you can move on. I still do think if you haven't 100% grasped this video is so important, it's ridiculous. Alright, so let's have a look at this other one. This one doesn't have any brackets, but hopefully just kind of more practice. This one's pretty straightforward actually. Minus 10. Alright, so guys, what we're going to do to each side. Actually, this one's a good example. This one's a good example for one reason. So imagine you're looking at this. Now, here's what some of you will do. So I'm going to do it the way which some people do it. And then I'm going to show you a way not to fall into that. So, you know, here, so let me do that as well. So I'm going to put the X's in red again, because I just want to make it absolutely clear to you. Remember, we're not doing any rules. All we're doing is we're just trying to get to our aim. We just want X by itself. Obviously here you can see there's X on both sides of numbers, so we need to sort that out. So this is what a lot of people do. And it's not wrong. It'll give you the right answer. But I'll tell you why I don't like it. They'll take away 5. So take away 5 from each side. I'm not going to bother doing it every step on the scales, but I hope you should follow me. It becomes minus 15, minus 10, minus 5, minus 15. And then they take away 12x here. So you get to, I'll actually write this. Minus 12x equals minus 15x. 10x minus 12x is minus 2x. So be careful with that, by the way. This shouldn't be x, by the way. I don't know why I put the x there. So you get to this stage, now you have to divide. And you divide by minus 2 here. Because this right now is minus 2 times x. So if you divide by 2, you're not going to get rid of that minus. If you divide by minus 2, then it's got rid of it. So you've got to divide this by minus 2 as well. So you get to the point of x equals minus 15 over minus 2, which is, if you guys know, if there's a minus on top and bottom, obviously it's just like, that just becomes 15 over 2. Running out of space. So the answer is 15 over 2. So, and that's the right answer. That's the right answer. But do you notice there were a lot of negatives involved there? But I think some people sometimes, you know, get confused with, oh, why does this become positive? And here's the reason why. Hopefully you guys can kind of see it. Remember, you've got to watch how you cancel fractions. There's a video where I'm like, how you cancel anything in a fraction. Hopefully you guys are happy that minus 15 is minus 1 times 15. Minus 2 is minus 1 times 2. So do you see, look, top and bottom is now changing things, multiplying. Look, the same number on the top and bottom is mine. I can get rid of it. That's why I'm left with plus 15 over plus 2. Alright. So here's what I don't like about this method. I think it's pretty well, should be avoided. So, and this is it. This literally is it. If I had, instead of that, written this question like this, which by the way is exactly the same question, let me tell you, so here's how I did, right? Let me show you exactly what you guys would have done. You would have added 10 to each side, so now we're at 12x equals 10x plus 15. Then you would have taken 10x away from this side. 12x minus 10 is 2x equals 15. Then you divide by 2. You get 15 over 2. See? Much easier. But here, so a lot of you guys, maybe not you guys, but there's loads of students, and I mean loads of students, who seem to think that you've got to get your x's onto this side. Yeah? Just for some reason you've got to move all your x's that way, you've got to move all your numbers that way. It's not true. Because here's the thing, it doesn't really matter what side. You can rewrite this as that. So for example, I mean, like, you know, someone told you to solve that. That's exactly the same as them saying that. So here's what I say. Here's a general rule. Look at which side has the most x's and move the one with the less x's onto the other side. There's a general rule from you. You don't want negative x's if you don't have to. It just gives you one less place where you can slip up. Hopefully that's clear what I just said. So yeah, don't fall into that trap. I mean, you'll still get the right answer, but there's more chance of you screwing it up. So don't do that, basically. Alright, I'll give you one more anyway. 2x plus 4 equals... So hopefully you guys are happy with this. Drawing scales. Yeah, so again, look, this is the annoying thing with this one. So again, you've got x's, you've got two x's, they're on opposite sides and they're stuck inside brackets. So here's where the rewrite part comes in. We're going to rewrite all of this and all of this. Now all we do with that is just expanding out brackets. So here's the deal. So if we expand this out, we get 10x plus 20 equals 4x plus 32. And then it's straightforward enough after that. So I'm going to move the x. So, you know, I mean, it doesn't really matter. Either I can take away 4x from each side, or I can take away 20, or whatever you want to do. Let's go a different route just for the sake of showing you. So, okay, let's take away 4x this time. Hopefully you guys see. This becomes 6x plus 20 equals 32. Take away 20. So 6x equals 12. 32 minus 20 is 12. And finally, divide by 6. X equals 2. And remember, you can now also, just to be under 100%, you can plug that in. Just make sure you haven't made like a silly little mistake somewhere, and as long as these are balanced, you've got it. Okay? So guys, really, really, really understand this video. This video is, if you get this completely, if this makes sense to you, if you understand that you never do anything to this or this or this, or right, you do it to one whole side and you do the exact same thing to the other side. It's the only way. It's the only way. Yeah. Think about the scales when you're unsure about a move. Think about the scales. In the next video, I'll show you how to rearrange equations. It's exactly the same. If you understand this, there's barely anything extra to learn for rearranging equations. Rearranging equations is where literally, so you'll get something. I'll do it in the next video. Just watch the next video, I'll show you. But yeah guys, huge important video. If you understand this well, then there really isn't actually that much more algebra coming up after this. Here's literally what there is still left. I think, if I remember the top of my head, I do actually have it written down somewhere. Let's have a look. Okay, I'm then going to start showing you how to solve these kind of equations where, like, you've got a fraction, which is, you might get something like this. Yeah, I'll show you how to do that. But it's going to follow the same stuff as this when you think about it. So make sure you understand the scale stuff. After that, what we're going to do, I'm going to show you quadratics. Again, I mean, that's different. That just uses a little few like different other tricks. But again, you're going to start with an equation. You're going to try to find out what x is by itself, right? And you're going to have to think about this. Simultaneous equations, surds, inequalities, blah, blah, who cares? I'll talk you through the videos as we go through it. But yeah, watch this again. If you don't fully understand this video, watch it again. It's that important. If you basically understand everything up till now, which I put in the videos, you are, I would say, 70% there. It's a number I'm pulling out of the air kind of thing. But yeah, it's basically, you're really close to more or less just perfecting algebra. You might have to go over these videos again. Yeah. Here's the other deal. If there's any part you haven't understood in this, come to me. Talk to me. I'm your tutor. I can talk you through this. These are obviously just videos, which I'm just making so you guys can kind of like, you won't forget and you can recap any time. But I'm not expecting you to understand these perfectly. But yeah, alright. This point, almost kind of think of this as like a checkpoint. I don't know what I'm writing. That would be quite nice. Right, this is your checkpoint now. Get very good at this point. If you're good at this point, well done. Right, let's move on. We're going to talk, and I'll see you in the next video. Okay, see you guys.